Hello guys, welcome back to the universe of tech. Previous video we will learn about in-order traversal and pre-order traversal. In this video we will learn about pre-order traversal. First we need to understand what is post-order traversal. In a post-order traversal we visit a node in the following order. Like first we need to traverse the left subtree. First it needs to visit the left subtree and next is traverse the right subtree. Next it visits the root node. We move on to the why use post-order traversal? In post-order traversal is a particularly useful for deleting a tree or evaluating a postfix expression in expression trees. This is the algorithm for post-order traversal. This is the definition for post-order traversal. The nodes are visited in the following order. First it visits the left, next it visits the right subtree, next it visits the root node. We move on to the, I am taking one example to show how to do post-order. First, it visits the left child, that is B, and child of B is the left child is B. Then it visits the E. Next, it visits the root node B. Move to the right subtree. The right child of C is F. It visits the F first. It visits the next C. Then it visits the A. This is the result of post-order traversal. It first visits the D, next it visits the E, and it visits the B, and next it visits the F, and it visits the C and A. This is all about post-order traversal. Move on to the coding part. First, we need to define a class. First, we need to create a class. Define a method, self and key as the parameter. Self and key as the parameter. Next, self dot left is equals to null. Next, self dot right is equals to null. Next, self dot value is equals to key. Self dot value is equals to key. First, we have a class node called as a node. This class is represented a single node in our binary tree. Each node has the three attributes, that is left, right, and value. The left and right subtrees will point to the node's children. Value stores the value of the node. Initially, both left and rights are set to the none, indicating that the node has no children when it is created. Next, we move on to the post order traversal function. We need to write post order traversal function. I need to define post order traversal root as the key, root as the parameter. Perform the post order traversal of the tree if root post order traversal of root dot left. It visits the first left subtree, and post order traversal of root right, root dot right. Next, it visits the root dot value. It prints the value root dot value is equals to it is equals to First, we define the post order traversal function. This function takes a node as an input and prints the value of the nodes in the post order. In post order traversal, first we visit the left subtree, then the right subtree, and finally the root node. If the current node is none, the function is simply returns, preventing an error. Next, we need to build the trees. Define, build tree, build a binary tree based on user input. The root value is equals to input. Enter the root value. Enter the root value. Next, root is equals to node of root value. We start by asking the user to enter the root value, which initializes the root node. We use a queue to keep track of nodes whose children we still need to set. While first we need to create a queue. Use a queue is equal to root. Then while queue current is equals to q dot pop 0. Next, input for left child. The left value is equals to input of enter the left child of enter left child of current dot value null no child if no child none if no child if left value dot lower is equal to null the current dot left equals to node of left current dot left is equal to node of left value q dot append current dot left. Next, input for right child. The right value is equal to input of enter the right child of value current value or none if no child. If right value dot lower is not equal to none, the current dot right is equals to node of right value. Next, q dot append dot append current dot right current dot right. Next, it returns the return root. Track of nodes whose children we still need to set. This allows us to build the tree level by level. For each node, we prompt the user to enter the values for the left and right children. If the user input none, we simply do not create a child node. This process continues until all nodes are added and we return the root of the tree. Next, we move on to the main. If name equal to in print building a binary tree root is equals to build tree. The root is equal to next print post order traversal of the binary tree is post order traversal root. This is the final. We have the main block of the code that runs when the script is executed. It starts by notifying the user that we are building a binary tree. After building the tree using a build tree function, we perform the post order traversal and print the values of the nodes. Enter the root value is A, the left child of A is B, the right child of A is C, the left child of B is D, the right child of B is E, the left child of C is none, the right child of C is F, left child of D is none, the right child of D is none, the left child of E is none, the right child of D is none, the left child of F is none, the right child of F is none. This is the post order traversal. First it visits the left subtree, then it visits the right subtree, then lastly it visits the root node. It is all about post order traversal. If you like this video, please don't forget to subscribe, like and share and comment in this video.